Everyone has cameras. Some are small, some are just their phones, and some come with a lot of buttons. And they all do most of the work for you. But for those with ambition and a fondness for pressing buttons, here's everything you need to know about cameras. If cameras and light would post about their relationship online, it would say it's complicated. They don't do well without one another, but there's always too much. And while you can control light on the inside, it gets increasingly hard on the outside. Instead, adjust the camera. There are three major ways to manage light: shutter speed, aperture, and ISO, resulting in the exposure triangle. First up, shutter speed. Imagine light as a constant stream of particles directed at the camera. The shutter is like a gate that only opens for a certain amount of time. Shutter speed is measured in fractions of a second, and the longer the shutter stays open, the more light gets inside. But longer shutter speeds also increase the chance that any movement is going to be blurry in the final image. To still get sharp images, you need a fast shutter, but that way you also get less light into the camera. One way to compensate for the lack of light is to increase the aperture. The aperture is a spherical opening in the front of the lens. At its widest, it lets in all of the light, but the smaller it gets, the less light can enter the camera. The F number describes the ratio between the focal length and the aperture's diameter. The bigger the number, the smaller the ratio, the smaller the aperture. Each step down the aperture ladder comes with a factor of 1.4, but the amount of light is proportional to the area. It decreases with a factor of 2, or 1.4 squared. At a constant shutter speed, the larger the aperture, the brighter the final image. That's why some lenses are faster than others. They allow for faster shutter speeds. Aperture and shutter speed control how much light gets into the camera. Once the light is inside, the camera's image sensor takes over. It's like a chessboard, with each field being its own light-sensitive sensor. Every one of them has just a single job: measure how much light gets inside. And just like that, you get a black and white picture. The more light hits a part of the sensor, the brighter it ends up in the final image. To add a bit of color, turn one sensor into 3. One for red, one for blue, one for green. But of course there aren't just 64 pixels on a sensor, but instead a couple of million. That's how you end up with all those megapixels. Since space in phones is limited, more tiny pixel means less space for each individual tiny pixel. So this is where ISO, or the film speed, comes in. Every image sensor translates light into a signal. If there's only little light, the result is a tiny signal. So like a microphone trying to pick up the faintest of sounds, you need amplification. The smaller the pixel, the less light it gets, the smaller the signal and the more amplification is needed. And the ISO describes the amount of amplification. Whenever a small signal is amplified, you end up with noise, which is exactly what you see in the darker areas of nighttime pictures. Larger pixel creates stronger signals and need less amplification, and create less noise. That's why more pixel does not always result in more quality. Sometimes less but bigger pixel can create better images. The term ISO is a remnant of the days of actual film stock, and was standardized across multiple manufacturers by the International Organization for Standardization. The guys that make parts from Europe also fit in the US. So how do all of these work together? In stops. Each one changing the amount of light by a factor of 2. Remember shutter speeds? The most common ones start at 1/1000th of a second, and then 500 to 50, 125, 60, 30. And what about aperture? 1.4, 2, 2.8, 4, decreasing the amount of light by a factor of 2, with the F number rising by the square root of 2. And lastly, ISO, 100, 200, 400, 800, sensitivity to light, and of course a factor of 2. There is one more option, a way of correction: the exposure value. Increasing it by one stop has the same effect as increasing the ISO by one stop, or decreasing the shutter speed by one stop, or increasing the aperture by one stop. It makes the image brighter. This obviously also works the other way around. One example where all of these work together is the sunny 16 rule. On a sunny day, set your aperture to f16 and keep the ISO and shutter speed more or less equal. So if the shutter speed is 1/125, closest ISO is 100. Shutter speed 1/500, closest ISO is 400. And you'll get a good exposure. So that's the baseline, and where you start to adjust. Increasing the aperture by one stop doubles the amount of light coming in, and you'll need to compensate by increasing the shutter speed by one stop, or decreasing the ISO by one stop, or just leaving everything as is and lowering the exposure value by one stop. It's all about getting just the right amount of light into the camera. If you enjoyed this video, hit the like button and consider subscribing. Also, if you want a friend to know how his fancy camera actually works, share this video. Thanks for watching.